minus 24. Okay, so what exactly is partial fraction decomposition? Well, the idea is to break this into two smaller fractions. If you are familiar with the term decomposition, you should know it's the breakdown of something. This gets used in business, it gets used in biology, and now it's used in mathematics too. You have this term in physics, as of course, in chemistry it's also decomposition. So what do we actually want to do here? Well, first things first, we need to factorize the denominator. Okay, because we want to break it into two separate little fractions. So to do that, we need to factorize. So I can say, well, this is x plus 8, x minus 3. Is this true? Let's see with my little box of evaluation. Well, I have, in this case, I have negative 24. This would be a times c. So whichever values here and here, multiply together to find this one. And here we have 5. So the factors of 24 is negative 8 and, let's say negative 8 and negative 3, because I want to get to positive 5. So which one's going to be positive? Well, it's going to be 8 minus 3 gives me 5. So this seems correct. Now, the idea is to assign this one as assign these two factors, linear factors, that's their name, assign them as individual fractions, but give them a notation a and b. Okay, x minus 3. Okay, so what exactly do you do now? Well, the idea is to eliminate. Now we have a new idea. After you factorize, you assign them two separate fractions, a and b. So what you can do is, it's actually very simple. You can just copy this down as, I'm going to tell you guys a little easy technique, but I'll get into the theory in a bit. So just copy it down, bring this one down, and then multiply this and multiply this. So that gives me a x minus 3 plus b x plus 8. So how did I get here? Well, I got here by, the idea is to multiply both sides with the denominator of the first fraction. So it's going to be 8 plus x and x minus 3. So look, if I cancel out this one with that, I'm left with a multiply x minus 3. And that's how I got this part. I'm just skipping this step. Okay, and why did I bring this down? Because if I multiply this side with x plus 8, x minus 3, I can see, well, this cancels that, and I'm just bringing this down. Okay, now from this point, what do we do? Well, now the new idea, another idea, is to create a 0. You want to either create b as a 0 or a as a 0. I like to start with solving for a, right? So look at this. We can say when x is equal to negative 8, because what happens? What happens if I set x equal to negative 8? I have negative 8 plus 8. That gives me 0. It will be 0 multiply b, which is 0. So all of a sudden we eliminated b. Now we can solve for a. So I can say, well, negative 8 minus 25 is going to be equal to a multiply negative 11. Why? Because negative 8 minus 3, that's negative 11. This gives me negative 33 is equal to negative 11a. I can divide both sides by negative 11, so a is therefore equal to 3. So guess what I'm going to do now again? When x is equal to what? So in this case, it's going to be 3. Because if I say 3 minus 3, I get 0. And then 0 times a is 0. Okay. So when x is equal to 3, let's solve. We have 3 minus 25 is equal to b. What's b? 8. 3 plus 8. This gives me negative 22 b 11b. Okay, 11 times b. I'm going to divide both sides with b with 11, so b is equal to negative 2. Okay, so what do we do now? Well, now we can say, now I need to go find my original equation. Where is it? Over there. Okay, even though I'm going to finish my equation over here, I can say now if x minus 25 over x squared plus 5a minus 24, if this is equal, and then I can say this is equal to, if I'm given that function or that equation, I can then say, well, a, I just calculated a is 3 x plus 8 plus, oh no, it's going to be minus because we have a negative 2 minus 2 over x minus 3. And then this will be my final, actually this entire statement will be my final answer. Okay, so this process is called partial fraction decomposition, and again the idea is to create two separate fractions. You want to first donate notations, or give some notations to the boys, which is then you first want to give some notations to the gang, and we have a and b, and then our main objective is to solve a and b so we can make a final statement. If this is given, then we can set this equal to 3 minus 2a. And now let's see if this is true. Well, now I'm going to test this just for educational purposes. So to test this, I can say, well, x plus 8 minus 2 x minus 3. How do I so when I add these fractions together, I'm going to multiply both sides with the denominator, since I want to create the same denominator, right? So I can multiply both sides by 8 plus x plus 8, x minus 3. So this one cancels with that one, so I'm left with 3x minus 3, right? Yes. And I want to subtract this from, this one cancels with this one, which is 2 x plus 8, and I want to put this on the denominator, which is x minus 3, and now I just solve with algebra. So it's going to give me 3x minus 9 minus 2x minus, what's that, 16, over I'm going to use the FOIL method, which is going to be x squared plus that gives me 8x, 3x, that's 5x minus 24. And when I add these values together, the same unit, I get x squared plus 5x minus 24. Now in this case, that gives me x minus 25. And there we can see x minus 25, and look at that, we have the exact same fraction. Okay, well that's partial fraction decomposition. And just to familiarize yourself with this term, well, this is called a linear factor. Because the x's value is only equal to 1. So if we had to solve this using asymptotes, we can say, well, x minus 3, and that concept you'll be familiar with a little bit later in calculus, where you have to solve asymptotes for certain functions. Okay, so that was partial fractions. Super duper easy.